In this video, I'm going to show you how to create a machine vision job in AutoVISION machine vision software, and how to monitor the results of the job using AutoVISION's features, Microscan Link, and Cloud Link. The first step is to connect AutoVISION and a machine vision camera. I have already set up a 2-megapixel VisionHawk smart camera, which AutoVISION has automatically recognized here. Once we connect to the camera, the next step is to create a new job. We'll review the image taken by the camera in the image view. Here, we can make changes to the exposure, gain, and lighting settings to ensure that we have a clean, high-quality image for the software to inspect. Now, we'll go to Edit mode to build our machine vision job. The machine vision job consists of images taken by our camera and inspection outputs that communicate information about the inspection to the outside world. The job is created by adding inspection tools to our image in order to acquire information about the object that we are inspecting, which can be communicated to the outside world through various output steps. In the center of the screen here is the image being captured by the camera. On the right side, you can see the parameters of any inspection tools that have been applied to this job, which appear in a list on the left side of the screen. At the top are all of the available machine vision tools in AutoVISION. The first tool is Locate, which can be trained on the outline of a shape and will continue to find the same outline on subsequent images. Locate can also be used to give other inspection tools relative positions on the image. The second tool is the Decode tool, which is used to read any barcode symbology, including dot code. The Decode tool can be applied to areas of the image that have codes in order to position other inspection tools relative to the positions of the codes. Next, there's an OCR tool for reading printed text. This tool contains an advanced IntelliText OCR option, which can be enabled to read the toughest characters, even in low contrast conditions or on poor backgrounds. The Count tool counts objects based on masses of uniform pixels in an image, and the Presence-Absence tool determines whether objects in an image are missing based on areas of contrast or intensity. The Measure tool measures distances or angles on an image to ensure shapes in the image meet all required specifications. Next, the Match String tool allows you to match the strings of data that have been output from two other inspection tools in the job. For example, you can compare output string of the Decode tool and the output string of the OCR tool to see if they match. The String Format tool allows you to format the output strings of other inspection tools. So, for instance, you can take the string of data from an OCR or Decode tool and adapt it to the format that you need for your operations. The Logic tool can take the output values from the other machine vision tools and combine them to make decisions or drive I/O processes. Lastly, there are verification tools. OCV for verifying the quality of printed text, and the Symbol Quality Verification tool for verifying the quality of 1D and 2D symbols. Creating a machine vision job is as simple as selecting an AutoVISION tool and dragging it onto the image and adjusting the region of interest. In this case, we'll drag the Decode tool onto the code that we want to read. And here you can see the string of data that is being decoded. Next, we'll use the Decode tool to help us position other inspection tools on our image by clicking on this Locate symbol here. Now, if I insert a new tool, like the OCR tool, it will maintain its relative position to the Decode tool as we receive new images from the camera. I'll insert the OCR tool here, and switch to IntelliText OCR to do more advanced reading of these printed characters. Next, I'll apply the Count tool to count objects in this image, such as the characters in the Microscan logo. The Count tool allows me to set a minimum and maximum tolerance. I'm counting 10 characters here, so I'll set a minimum and maximum of 10 expected objects. As you can see, the tool gives a pass reading. The Measure tool allows me to measure any distance on the image, for example, from the edge of the bottle in this image to the edge of the label. The tool measures this distance as 177 pixels. Like with the Count tool, I can set a tolerance for my measurement here. Let's say 160 to 180 pixels. With that, we are measuring exactly the number of pixels we expect, and the tool passes. Next, we'll check the quality of text in the image. For example, we'll inspect the 1 ounce text on the label here. I'll drag in the OCV tool and set my training window around the 1 ounce. Train on these characters, and when I zoom in, we can take a closer look at what the tool has been trained on. If I click on a character, you can see that the tool has been trained on this shape. It's currently inspecting this shape, and there are no differences, so the tool passes. If the printed text changes or isn't printed with the same quality, the tool will fail, and you can reject the poorly printed bottle. The last tool we'll add to this inspection job is the Symbol Quality Verification tool. It allows us to verify the print or format quality of symbols against published standards. When I apply the tool to this symbol, it provides me with a grade A, according to the ISO 15415 standard. I can pull up a verification report for this symbol, or even save it as a PDF. The next step is to make the data from my machine vision job available to the outside world. For example, I can communicate my inspection results to a TCP/IP interface or a PLC system, or to AutoVision's CloudLink HMI interface. In order to do this, I will use AutoVision's connectivity feature called MicroScan Link. First, I'll link the tolerances of my count tool by taking the parameter and clicking on the MicroScan Link icon here. This allows me to link the parameter to a PLC system over protocols such as Ethernet IP or Profinet I/O. MicroScan Link also makes outputs from this tool available for general use on the serial or TCP/IP interface. To connect, I'll just click the link icon and choose an open slot. I'll choose integer 101 for the minimum count tolerance, and for the maximum tolerance, I'll link to integer 102. Now when I open AutoVision's Data Navigator here, we can see what has been linked to the outside world. Here we see integers 101 and 102, which are connected with the upper and lower values of my count tool. If we take a look at the job view, we can see both values again. I can already make changes to my tolerances from here. If I want to change my values to 20, you can see it change here as well. And you can see that the tool now fails. I can change the value back to 10, and now the tool will pass again. I can do the same thing with output values. For example, I can take the decoded string from my decode tool and drag it to string number 1, linking it to the outside world. I can take the output string of the OCR tool, link it in the same way. I can take my OCR character count and link it to integer number 1. I'll take the count tool count and link it to integer number 2. I'll take the output from the measure tool and put it in float point number 1. And lastly, I'll take the status of my verification tool and link it to a flag on Boolean 1. Now, if I look at all of the linked values in the Data Navigator by including all value types, you can see all of the output values that I've linked and the 2 input values that are linked. These are available for generic interfaces and also Ethernet IP input assembly, Ethernet IP output assembly, Profinet I/O input assembly, and Profinet I/O output assembly. Finally, we can go to Run Mode, which downloads the machine vision job we just created to the smart camera and run it for live inspection. Here we can see our image and the results of all of the tools that have been applied. I can open up the Data Navigator again and refresh the tag list to see which values have been linked using MicroScan Link. I'll refresh the values as well to get the latest values from the inspection. Here you can see the strings of data that we acquired using the decode and the OCR tool, the number of characters in the OCR tool, and the number of characters counted in the logo by the count tool. Here are my 2 set points for the count tool, my measurement and the status of the verification tool. To mimic a PLC or external command system changing a set point, I can, for example, change this value for the minimum count to 20. Now you can see that the count tool fails because it's counting 10 and expecting 20. I can change it back again to 10 to make the tool pass again. Since these tools are linked across your network, you can make the same changes directly from a PLC system or by sending a command. Now that we've created our machine vision job and linked it to the outside world, let's open a web browser and visualize our camera's images and microscan link values through AutoVision's Cloud Link dashboard. Here, I'm going to show you how to visualize microscan link values and images using Cloud Link, AutoVision's web-based HMI solution. Right now, I'm connected to my VisionHawk smart camera through its IP address on a Google Chrome browser. I can visualize the inspection job on this camera by clicking on the Cloud Link dashboard icon. And now the dashboard will be loaded from the camera into my web browser. What you see here is a default layout that is stored on the camera, showing the image with the inspection tools we have already applied. It has two microscan link values already displayed here, and inspection counters showing pass and fail results. I can make changes to this layout by pressing the Edit icon. From here, I can add Cloud Link widgets to the different sections of the layout that are marked with a plus sign. For example, if I press the plus here, I can add widgets such as a single microscan link value, a chart, a log of microscan link values, a single image, like the one I have in the center of my dashboard, an image film strip, a header, or again, inspection counters. I can insert an image film strip here at the bottom and show the image history. I can add a second one here as well, and set the first film strip to show me only the failed images, and the second to show me passed images. If I make an image fail, we can see it show up in the top film strip. I can also add, for example, a chart to the top here, which I can use to graph microscan link values. In my inspection job, I've already linked the value for my label position measurement to float number 1. So if I choose float 1 for my chart, we can see the measurement values graphed here, ranging from 177.1 and 177.4 pixels. At the left, I can edit my microscan link values by changing the text. So if my inspection passes, we'll call the value pass. And if the inspection fails, the value will be fail. I can also change the color, depending on the results, by linking it to my inspection passed status. For example, I can have a black text against a green background if it passes, and yellow text against a red background if it fails. I can change the header text of my microscan link values and widgets by clicking on the text and changing it to something more meaningful. So, for example, we can change this to character count. I can visualize additional values here by inserting another single value and linking it to another microscan link parameter. For example, if I want to see the results of my OCR text, I can link it to microscan link value string 2. This is my OCR text. Here we can see the expiry date. I'll call this section expiry date. I can also move the position of these values by using the arrow buttons. The last widget I can add in my dashboard is the log of values widget, which I can also link to my microscan link values. For instance, if I want to see the number of characters in my logo, which is linked to integer number 2, here we can see that the value is 10. If I obscure the image a bit, we can see its value change in the log and the tool fails. The next step is to save the layout on the camera and leave edit mode. Now we can see the live inspection job running and visualize all of the tool values. If I interfere with the image, we can see that subsequently the tools fail, and corresponding tool values change as well. I can also stop updating the HMI by pressing the pause button and then take a look at the failed image. If I click on it, we can review what was wrong with it. With an image selected, we can also see that the corresponding values update in the other widgets to show the failed data. I can also select a value. For example, this 3. If I want to know what this was, I can double-click on it, and we can see the corresponding image and data will appear for review. This is how easy it is to create a machine vision HMI interface using AutoVision's Cloud Link dashboard.